The world watched in amazement and horror as the most violent volcanic eruption our planet has experienced in 30 years sent massive shockwaves through Earth's atmosphere and out into space. The extraordinary blast of Tonga Ha'apai was heard as far away as Alaska and was seen by orbiting satellites. Even atmospheric gravity waves were detected by a NASA satellite, and dozens of concentric circles of gaseous waves may have circled our world several times. What does this mean for global weather patterns, earthquakes, and even a new ice age? Welcome to Factnominal. In today's video, we plunge deep into the extraordinary event that literally shook our Earth. What does it mean for the near future, and is it a warning that humanity must heed? At about 5:10 p.m. local time on January 15, 2022, a blast 1,200 times more powerful than the atomic bomb dropped on Hiroshima unleashed terror on the residents of the beautiful archipelago of Tonga in the South Pacific Ocean. Government officials there report waves nearly 50 feet high from the ensuing tsunami, and recovery will take years. What the rest of the world saw was also shocking. The initial blast generated so much upward force and heat that it sent a plume of ash and vapor over 34 miles into the mesosphere, well over 3 times as far from Earth's surface as air normally rises, and the highest cloud ever seen. Barometers around the world bounced up and down at least 3 times from the circular shock waves exploding from the South Pacific. In fact, the pressure waves spread around the globe initially at 700 miles per hour, faster than the speed of sound, and created sonic booms that nearly reached the Arctic Circle. Weather officials in Seattle credit the explosion's shockwaves with temporarily lifting the city's fog. One reason for the sheer ferocity of the explosion was the relatively shallow depth below the ocean's surface, roughly 490 to 820 feet, that gas-rich magma contacted seawater. When the magma came out, there wasn't much pressure on it, says Dr. Shane Cronin at Auckland University in New Zealand. The gases expanded and blasted the magma apart. And then, as those little fragments of hot magma encountered the cold seawater, you flash water into steam and basically expand the volume by 70 times, so you supercharge your eruption. Met-Op satellites that measure weather from orbit recorded temperature fluctuations as the wave descended in the atmosphere, causing air to warm by compression. And we haven't even mentioned the light show. The plume produced almost 400,000 lightning strikes within just a few hours of the eruption. That's more than 5,000 a minute. Lightning is beautiful and deadly and a regular occurrence, but scientists weren't prepared for a sight not seen in previous volcanic eruptions, a striking pattern of atmospheric gravity waves. It's really unique. We have never seen anything like this in the data before, says Dr. Lars Hoffmann of the Jülich Supercomputing Center in Germany. What he's referring to are ripples in space. NASA's Aqua satellite studies Earth's precipitation, evaporation, and cycling of water, and every day its atmospheric infrared sounder, or AIRS, gathers infrared energy emitted from Earth's surface and atmosphere globally. Images collected by AIRS are startling, showing dozens of concentric circles stretching nearly 10,000 miles while circling the planet. Air molecules in the atmosphere are normally moved horizontally, though mountaintops and localized weather events can push them vertically. When this happens, atmospheric gravity waves result. Those very high clouds that look like ripples are the result of this upwards pressure. But nothing scientists have seen, even from previous eruptions, compares to the effects of energy from the sudden explosion of hot air and gas after this monumental event. Picture the sound waves from striking a musical instrument reverberating outward, or the ripples on a pond from a thrown rock, and you'll get a good visual of the global force unleashed through our atmosphere and beyond by the underwater volcano's powerful eruption. Scientists are watching the worldwide effects closely, as gravity waves can impede periodic reversals of wind directions, thus affecting weather patterns. And there's a very fortunate but mysterious aspect of this event that puzzles scientists. Why didn't more people perish? Out of 181 countries, Tonga is third from the bottom for its vulnerability to natural disasters, according to the World Risk Index. The Hunga Tonga Hunga Ha'apai volcano, which sits in the aptly named Ring of Fire, erupted around 43 miles north of Tonga's main island, where almost 3/4 of the archipelago's population of roughly 105,000 lives. Political leaders say Tonga expects tsunamis, cyclones, and earthquakes, though not on this scale. And perhaps this preparedness and mindset saved hundreds or even thousands of lives. Also, the volcano had been blasting lesser eruptions since December. A radio reporter on the main island, Marianne Kupu, said the final eruption sounded like a bomb exploding, alerting the populace to head for higher ground. Our ears were ringing. We couldn't even hear each other, she said. The only thing that kind of scared us was that the disaster was different from the previous ones, which is always tropical cyclones. Tsunami waves close to the eruption reached almost 50 feet high. Thankfully, tidal gauges measured the waves at just over 3 feet when they reached the capital, though tsunami waves are very different from the normal variety. The sheer pressure and volume of water causes severe property damage and tosses vehicles like children's toys. With that in mind, are more eruptions coming in the South Pacific and earthquakes? According to Dr. Andreas Cronenberg of Texas A&M, the entire Southwest Pacific has what we call stratovolcanoes. These are extremely powerful volcanoes and are also the kinds that include Mount Vesuvius that covered Pompeii in Italy. It's possible such an eruption could trigger nearby activity. Researchers in New Zealand also warn that studies of previous eruptions of this volcano suggest it may be active for several weeks or months. This particular volcano was also unique in triggering the first ocean-wide tsunami in the Pacific not caused by an earthquake, and, of course, for giving a spectacular view from space. Interestingly, one of Europe's 2 satellites that are its eyes on the planet's weather, Sentinel-1B, went dark 2 days before Christmas, and it's not waking up. Speaking of weather, what can we expect in the coming weeks and months and beyond? Around 400,000 tons of sulfur dioxide were blasted into Earth's atmosphere, and while this results in acid rain and affects Earth's climate, we caught a break this time. A big break. This volcanic eruption lasted several minutes. Remember that this latest volcanic eruption is the largest in 30 years. Well, as powerful and awe-inspiring as it was, it pales in comparison to the Mount Pinatubo blast in the Philippines in 1991, 30 years ago. That spectacular event, the largest eruption of the last century, blasted exponentially more material into the stratosphere for roughly 9 solid hours. That time, about 15 to 20 million tons of sulfur dioxide went skyward, and the largest stratospheric sulfur dioxide cloud ever measured by modern instruments hung over the planet for the next 3 years. The sulfur dioxide reacted with atmospheric water to form a hazy layer of aerosol particles circling the globe, 10 to 100 times normal levels. These scattered and absorbed incoming sunlight, cooling the Earth by an average 1 degree Fahrenheit over the next 15 months. And while we're noting planetary changes due to Pinatubo, sunsets were considerably more colorful for many months afterwards. So, what do you think about this phenomenal eruption? Would you pull out your camera to record such an event, or would you run for your life? Tell us in the comments. And as always, thank you for watching Factnominal.